That's all I have. I know a lot of you, talked about job issues. It's a lot of fun. It's great to wake up in the morning and feel like you're doing something that matters. I talk to my kids about it, and I'm proud of it. I've been doing renewable energy for about 15 years, biomass, solar, wind, and it's a great thing to be a part of. It's not easy. Nothing is supposed to be easy, but it's a lot of fun, and I think Chance and I would both tell you that it's just a great thing to be a part of. So, Chance, why don't you come up and we can answer some questions together. Well, the question is about the long-term, is this on? Yeah. The long-term price and availability of natural gas. If I really knew, I'd be telling my broker. But I can tell you what reputable consultants are telling us. Wood Mackenzie is one of the, I'd say the two leading global gas consultancies, and their long-term forecast for the price of gas in real terms is about $7 per MMBTU, per 1,000 BTU, out through 2035. All right, so right now gas is about $4, and they're saying, in real terms, inflation adjusted, $2010, you're not looking at much higher than 7. Now, if there's a change in political dynamic in the United States and somebody's presents some credible scientific evidence that there are environmental hazards to, fracking for natural gas, which so far that evidence has not been presented, and it certainly hasn't been accepted. But if that were to happen and suddenly we were to clamp down, that would certainly raise the cost of natural gas, but it's not in my mainline projection. When I talk internally in my company, I tell people that if you're just holding your breath waiting for natural gas to go away, you're in the wrong industry. If we want wind to succeed, we need to have a cost structure that can compete with the big boys.
I think on the technical side, you mentioned journeyman electrician. Absolutely. Electricians, we need electricians that are licensed and can cooperate and adhere to jurisdictional requirements. And CAD designers, people that are capable in like a Google SketchUp, AutoCAD, that kind of software. I see those as being positions that'll be in pretty high demand on the technical side.
Yeah, I'm afraid I'm not the best person to speak to specific technical requirements at Vestas, but I would stress not just mechanical, but also electronics and electronic controls, as well as a real demonstrated commitment to safety. So I think you're asking, let's see if we can triangulate on it. I think you're asking whether we design individual turbines or product lines. So we, at any given moment, are selling 4 or 5 different kinds of turbine, primarily distinguished according to wind class. And wind class means wind speed and turbulence, usually. Now, when we design a project for a specific location, we can, fine-tune, exactly what features, are included. But, like a car company, we have a small number of basic platforms because the R&D, to design a new wind turbine, is a good 5 years, of design work, right? So typically you're talking about the same platform with the same basic approach, basic components, to which you add things that fits the customer's unique circumstances. I guess more than that, we do a lot of work with customers to design the actual wind farm in terms of microclimate and micro siting, so that the actual wind turbines are in the right place to catch the right winds, and so that you don't have wake effects from the wind passing one turbine and then impairing the performance of the next turbine, either through blocking the wind or creating turbulence that will start shaking components down there. you don't have to worry about shaking components most of the time, but it's the thing you worry about with any mechanical equipment. So turbulence, but again, that's not so much, the guys in the lab worrying about. That's our, site design people, closer to the field that worry about that. I don't think I really answered your question, but I kind of circled around it.
Sometimes. For home storage, yeah, absolutely. You could do a hybrid system where you can exchange power with the grid and then also feed into a battery bank. Typically what people don't really realize or consider with a hybrid system like that, where you can store electricity and energy, is that, one, it's extremely expensive. You take maybe a $20,000 system and you can quickly turn it into a $60,000 system, so you need to be budgeted for that. And if you are, then they're also extremely intensive. You have to go down there with a hydrometer and check the specific gravity on the batteries once a month, once every 3 weeks, and it's going to take you some time. So they're high maintenance, those type of systems. So typically what my customers end up doing is a backup generator if they want that kind of situation that feeds into their service panel. And then they've got their solar. If the grid goes down, their solar power goes down. It's required to shut down within 5 milliseconds, and then their generator, they'll just hit their transfer switch, the generator will come on. That usually, almost always, is more cost effective for them. Second part of your question, repeat it again. I got you.
Well, I'll just chip in from the wind side. If any of you are interested in energy storage, that's the holy grail for the wind side. I mean, wind is predictable, but you can't control it. And in many locations, it doesn't blow at the time when people need electricity the most. And that really cuts the economic value of the electricity that we produce. If somebody could come to us with a cheap energy storage solution, whether it is a battery or a flywheel or something else, that would raise the eyebrows. Right now, you do see some pilot battery-based or other energy storage approaches, with wind farms, but typically in places like Hawaii that really have expensive electricity, right? Because Hawaii makes its electricity out of barrels of oil, and that's expensive, and it's coming in on a ship, right? So that's expensive, as opposed to a pipeline. So there are projects that are being planned and built and operated in Hawaii that incorporate energy storage. But if you could lower the cost, most people, I don't want to say most people, a lot of people would say that they're not holding their breath for a battery-based storage solution. People are looking at things like compressed air storage, for wind. So when the way you do it is you're saying, well, when the wind is blowing, we are going to pump air down into salt caverns and compress it, and then when the wind isn't blowing, or when the wholesale price of electricity is really high and we want to sell power for a lot of money, then we'll let that compressed air out and run it through a generator, and that's how you do it. So storage is real interesting to us as well. I also wanted just to contrast, for solar, it's real important for these guys that their stuff goes offline if there's a fault in the grid, because the line workers, when they go to pick up a dead line, really want to make sure that there's no electricity coming the other way, right? Wind farms, it's real important that we don't go offline when there's a fault, because we operate as utility scale power plants. So there are increasing regulations for things like low voltage ride through, high voltage ride through, frequency ride through, so that when there's a fault in the line, the wind turbine keeps producing power. What you see in a lot of blackout conditions is that there was a little glitch in the line and everybody's power plant tripped off, and it just cascades like that. And we are now making wind turbines, manufacturing wind turbines designed that can operate so as to support the grid by not tripping off automatically. So just different approach. You can do it so that the turbine continues to feed power in to keep voltage up in the line, so that the fault doesn't bring the grid down. We also have capacitor-based approaches so that we can vent the electricity as heat